A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
It's festive season, full of noise and music. You can see that there are many sounds coming from all sides. Have you wondered from where it's coming? Yes, it's from the loudspeaker. What would be the secret behind it? Let's see. Here, a metal rod AB is hanging in between the poles of a U-shaped magnet using a copper wire. The wires are connected to a switch and a battery. What do you observe when the switch is turned on? When the switch is turned on, the copper rod deflects to one side. What if the current is reversed? The conductor moves, but there is a difference. Now the conductor is moving in the opposite direction. Again, if we reverse the magnet, the direction of motion of the conductor changes. The motion of the conductor occurs when there is a change in polarity of the magnet or the direction of the current. What if these two elements are replaced at the same time? It moves. It is moving like what we have seen before. Here, the magnet has a magnetic field of its own. We have already learned that a magnetic field is formed in and around an electric conductor. Here, the conductor moves as a result of mutual action between two magnetic fields. When the direction of electric current is reversed, the magnetic field around is also reversed. This is why the conductor moves in the opposite direction. So, what can we infer? The direction of motion of the conductor depends on the direction of current and the direction of magnetic field. A British scientist, John Ambrose, formulated a law to understand the relation between the direction of magnetic field, current and motion of the conductor. Extend your left hand like this. Hold your thumb, forefinger and middle finger perpendicular to each other. If the middle finger shows the direction of current, the forefinger would represent the direction of magnetic field and thumb represents the direction of motion of the conductor. This is called as Fleming's left hand rule. Let us remember a code to remember the fingers which represent the data. The middle finger or the center finger gives you the current. Center finger C, current C. The forefinger will give you the magnetic field. Forefinger F, magnetic field F. And remember, the thumb would give you the motion of the conductor. If so, let us find out the direction of motion of a conductor here using this law. Extend the forefinger, thumb and middle finger of your left hand perpendicular to each other. Hold the hand in such a way that the forefinger is from A to B. It is away from the plane of the screen. This is because the current flows from A to B. The forefinger is from north to south, that is downwards. Now the conductor will be moving in the direction of the thumb, that is towards the right side. Now the battery is reversed to reverse the current. Hold the hand in such a way that the forefinger is from A to B, that is into the plane of the screen. The forefinger from north to south, that is downward. Now the conductor is moving in the direction of thumb, that is towards the left side. Let's learn something very important and interesting. In childhood days, we might have thrashed our car and took a motor out of it. Now, let's learn the inner side of an electric motor. The main components are armature, magnet, split ring graphite brushes. Armature is finely insulated coils of copper wire wound over a soft iron. The ends are soldered to two split rings. The armature is mounted in between two strong poles about an axis of rotation. The rings are in contact with a pair of brushes, but they are not fixed. An electric motor converts electric energy into magnetic energy and then into mechanical energy. Now, let's see the working principle of a motor. The motor principle, by definition, is a force exerted on a current carrying conductor when placed in a magnetic field. Now, let's see how the motor works. When electricity flows through the armature, a magnetic field is created around the armature. So here, the armature becomes a magnet. The armature rotates on its axis as a result of the repulsion that takes place here. In armature, the current flows from A to B. The direction of the magnetic field is from north to south. According to Fleming's left-hand rule, the direction of motion of AB of the armature is in the direction of the current, that is downwards. In case of CD, the current flows from C to D. The middle finger swings from C to D and the magnetic field lines from north to south. Since the index finger is perpendicular to the pole, the direction of motion of CD is upwards, according to the left-hand rule, that is, the direction of thumb. The armature coil moves as AB moves downwards and CD moves upwards. At the end of a semicircle, the split ring R1 touches the brush B2 and the split ring R2 touches B1. Then the part CD moves down and part AB moves up. As a result, the armature coil moves in the same direction. Split ring commutator helps to change the direction of the current after each half rotation. For the motor to continue to rotate, the current through the armature must be constantly changing. The split ring helps to change the direction of current in the circuit after each half rotation. Hence, it is also known as split ring commutator. There is another device that works with the magnetic field of electricity: moving coil loudspeaker. There is a magnet inside the speaker. Have you noticed it? It is a ring magnet. This magnet is a main component of a moving coil loudspeaker. Next, you can see a voice coil that can oscillate freely in the magnetic field. This coil is attached to a retractable layer. This part is called as a diaphragm. A moving coil loudspeaker is a device based on the motor principle. Now, let's see how it works. The amplifier amplifies the electric signal received from the microphone and transmits them to the voice coil. In general, a microphone converts what we say or record into electric signals. Since there is a very weak signal, they are strengthened by an amplifier. The voice coil is freely moving coils in a magnetic field. The diaphragm is attached to it and the voice coil vibrates according to the motor principle. The voice coil is freely moving coil in a magnetic field. The diaphragm is attached to it and the voice coil vibrates according to the motor principle as the electric pulses passes through the voice coil. The vibration of voice coil causes the diaphragm to vibrate. This causes vibration in the air in front of it. This vibration is proportional to the vibration from the microphone, that is a sound wave emitted in the air. These vibrations which occur in the air at high altitude make noise in the ears. Thus, the sound that reaches the microphone can be reproduced. The loudspeaker converts electric energy into mechanical energy and then into sound energy. The lesson ends here. This is a very important chapter which you have to remember. May this knowledge help you. Wishing you high success.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.